My name is Cedrik Neumann. I'm a resident solutions architect at Astronomer, and usually in my day-to-day work, I help our customers getting the most out of Airflow. But yeah, since we're at the end of the workday, let's think about after work. And in Germany, we have a saying for that. It's called Feierabend, which literally means celebration evening. So yeah, let's talk about what we do after work in our free time. In my case, I built a little, had a hobby project. And the bad news is I don't have a coffee machine here today. Yeah, but it's something very similar and comparable to one of the more modern coffee machines. Meet the Espressive ASP32 C3 Mini 1 system on a chip. So yeah, that's a mouthful. It's actually just that small part, similar in size to a euro cent or a dime. It's a single-core 32-bit RISC-V processor, 160 megahertz of clock speed, and only has 400 megabytes of flash. 400 kilobyte of memory. That's not a lot. And its power consumption is similar to your AirPods. But similar hardware can actually run Doom. Not this model, but some similar ones. But the big question is, does it run Airflow? And if you think about it, we have no operating system, no threads, no multiprocessing. Like running Python alone takes 18 megabytes of memory, not gigabytes, sorry. So you would say no. Well, the good news is now it does. Spoiler alert. So what did we need to do to actually make that happen? So first, you need a worker written in Rust. As well, you need DAGs and tasks written in Rust. Make everything asynchronous and then just compile it to a bare metal. That's it. We are done here. Well, let's talk a bit about how we got there. Why can we do it now? And why not just 2 years ago? And there are like two big features in Airflow 3 which made this much easier. The first is the Task SDK, which is not only like the software SDK to use, but also an API to interact with Airflow, which is standardized. It's an HTTP API, so you don't have to interact with the database directly. And the same with the Edge executor. It actually allows you to pull job information from Airflow via a standardized REST API. So in order to understand how big the impact of those two features is, let's have a little bit of background. So anyone familiar with Airflow 2 knows the security model is not really there. Everything can just access the database. So to visualize this a bit more, this is how it used to be. We have 5 components, and they all kind of directly talk to the database. And even worse, 4 of them run user code. So that's recipe for disaster. And in addition, we have an executor-specific implementation, how workers are actually being run, which is nice, it's flexible. But if you want to build something on top of that, usually you have a very large scope. Yeah, a lot of things you have to take care of. And in addition, you have to keep track of internal changes in Airflow, database schemas, and so on. So let's look how this would look like in Airflow 3 with an Edge executor. Now everything is nice behind an HTTP interface. Everything goes to the API server. Although DAG processor and Triggerer have their own in-process API server, you have a standardized API. The same for pulling jobs. So the scope now is much smaller. This is actually something a single person could do in 4 months. And so let's talk about how would someone want to do that with the Edge executor. How to write a worker. What are the things you want to do? What would you need to know? First, the Edge API. Those are not all things you can do with the Edge API, but I think those are the most important ones. The first, you need to register your worker. You send a payload to Airflow with your host name and also the Airflow version you expect to run against and the executor version. And then the server will either say, yeah, welcome, or no, you need to change your expectations. And once you have done that, you do a heartbeat with the set state of the worker. which allows you to also to communicate to Airflow, okay, oh yeah, I'm going to maintenance or I'm going to shut down, and vice versa. Airflow can tell the worker also to shut down via the heartbeat. And once your worker is running and it's heart beating, you can start fetching jobs. It's very simple. You just ask, give me a job, and you can run it. Once you have a job, you just tell Airflow either if it's running or it's failed or it's successful, which is not exactly the same as the TI instance or the task instance state. So it's more like a state of the job. So a successful executor can still have a failed task. And when you have all this done, the last thing you actually want to do is pushing logs. So usually, there are many ways to push logs, but in addition, the Edge executor has a way to push it back to the API server. The only thing you have to be careful about this is that pushing this is the logs for the same task instance concurrently might cause some race conditions. So stay sequential within the task. And if you want to know more, there's also the documentation for the API hosted in the web server, or API server, sorry. And so let's look how you need to actually structure your Edge worker. In Python, you start with a worker process. That process is interacting with the Edge API. It's managing the task jobs and it's uploading logs. And once you have a job, you actually start a supervisor process. That supervisor process is part of the task SDK, so it's a bit more standardized, and it's managing the communication to the execution API. It's also running the it's supervising the task runner process, to which we get in a second. And it's taking care of the task heartbeat. So if that process is dying, then Airflow thinks the task is not running anymore. And at last, we have the task runner process. And this is actually the part which runs your task. And it can communicate to the supervisor to get XCOM information, variables. This is all now isolated. So you actually don't call the API server directly. And in addition, all logs in that task runner are actually task logs. This is a very important distinction. So we have 3 processes. And coming back to our embedded device, we cannot do that, right? So instead, we just do it async. Now everything is a single thread and just running asynchronously. So I try to stay close to the original design, and because don't change a running design, someone might say. And this is, I think, the basics of what you need to know about running your own Edge worker. So if you're good in Java and you want to do it, this might be helpful. So now let's look at the Rust Task SDK, which actually lets you write tasks natively in Rust and run it. And the core at the Task SDK, for me at least, is the way how you define an operator. And it's very similar to a base operator in Python. You have a trait called operator, and it has an execute method. That's it. There's nothing more to it. It's just a Rust version of a Python base operator. And in addition, we have output, which needs to be JSON serializable. Usually, like in Rust, you can just implement serialize for this, which most types already do, or just pass an empty type. This helps you to just pass XCOM to your downstream task. So here's an example of a sensor, which is it's an operator trying to be a sensor, let's put it this way. And it's waiting for a button press, and once the button is there, we just pass it as output. And because button is serializable, it will be stored as XCOM in our database. And in the same way, when we have a downstream task, and that task pulls XCOM. And this is very close to how you would do it in Python, just a bit more rusty way. You have your task instance, and you call XCOM pull. And what exactly we do with that button, I kind of hid here just for the sake of space, but later maybe we can see it in action. And so what are the current limitations of the Task SDK? Well, variables and connections don't work yet. I focus on XCOM, but not just a matter of time, full task context. So all the things you can usually access in the context are not there yet, or even assets, like sending out assets is not supported. And also sensors actually was a bit more difficult than I thought. So this is coming later. It's because Rust doesn't really have inheritance. And at the end, I think right now I have a lot of boilerplate code just to define your DAGs and then run it in your worker. So to really have like something usable, I think you just want to write your DAGs, give it to something like a macro, and then that runs your worker automatically. So we will get there. There's some other things in Airflow which are a bit more tricky. So template rendering, dynamic task mapping, and DAG versioning, they all kind of depend on Python being very flexible and also don't work well with compiled code. So talking about the difference between Python and Rust, I think Rust, for good reason, is popular and notorious for its strict type checker and its ownership model. Yeah, and that is in big contrast to Python's flexibility, and which on one way is one of the key reasons why Airflow is so successful, I would say. So there was a bit of things I had to consider and to work around. And I mean, in Python, you run something which has an execute method. There's a bit more details to that, but it runs anything you give it to. You can also even monkey patch that method during runtime and do funny things. You have convenient globals to access XCOM, variables, and connections, and it makes heavy use of inheritance. And at the end, if there's a breaking change in your Python code, it usually just shows up in runtime. Unless you have a really good type checking setup, it's hard to detect those things. And then, in Rust, ownership really impacts how you have to run tasks and perform mutations. That's I think, one of the biggest obstacles I had. But once it compiles, it's usually you have a really good feeling. And I had a lot of refactors in doing this project. So relying on the type checker and the compiler to tell you, oh, everything looks sane, was a really good feeling. And of course, you still have to have a reasonable program to run. So Rust cannot know if your program actually makes sense. But that's good enough. And you have actually tight control about what your users can access. So I didn't have to deal with leaking tokens or whatever in my async single threaded code, because Rust just doesn't let the user access those things. And in Python, the only way to really isolate something is a process. But you have to work a bit around the non-existence of inheritance. Traits are good, but they have limits. And generics in Rust can blow up your type definition. So at one point, I had up to 5 generic parameters in my classes or my structs. And that was a bit ugly. I managed to kind of wrap it around like in a generic trait, but still. And especially with async, like dynamic dispatch doesn't work so well yet. So why doing all this effort? It's a fun project. It's nice to have, but what are the potential use cases? And I would say definitely, if you have resource-constrained devices, specialized hardware, or even exotic operating systems which don't work well with Python or Airflow, then that's something to consider. And to be more explicit, so some examples could be the automotive industry, household appliances, consumer electronics. You can run your workers directly in your test devices and do test runs or whatever. So working at the Task SDK, it's a very young thing in Airflow. And so there are more things we can add to it to improve it. And I think one of the things right now you have to do is you have to have a Python DAG in order to run a DAG or a task in a different language. Yes. So maybe at some point you actually can define your DAGs and tasks entirely in your own language, and you call it, you execute it or something, and you get some kind of serialized dark view, which you can push to the API server, and you don't rely on the Python dark anymore. And the same way, like a pluggable supervisor. If you want to run Rust tasks natively, you need a Rust worker. That's the only way. And maybe at some point you can tell a Python worker to run Rust code. Yeah, and the bash operator doesn't count here. So, and it's vice versa, like maybe you can run Java code in a Rust worker. Yeah, those kind of things. And at last, the Edge API has a very useful feature to push logs, which, especially if you don't have a file system, that's very useful. But there are many ways of actually sending logs to Airflow. You have either a local pass, because you're on the same host machine as the web server. You have remote log storage, and so on. So and maybe in the future, there's a single way how to send logs back from the task, which also works with external logging providers and so on. So yeah, something to think about. So yeah, now it's time for a demo. Actually, I have my worker here. So this is basically running the task I just showed earlier. You push a button and press and let an LED show up. And yeah, we'll just give it to Nathan. So you can just press any button. Wait, actually, I need to start my deck. Let's see. What does the display say? Idle? Okay, then you can press a button. Any of those three buttons, yeah. And there we are. Now you should see an LED light up. Yeah. So I cannot see it well from here, but according to the logs, you press the red button. And yeah, the red LED was turned on. So yeah, you were just running Airflow tasks on a coffee machine with XCOM. Thank you. So yeah, just to wrap this up, if you're interested in embedded Rust, I just recently discovered this YouTube channel, which really is close to what I did, or also the devices I worked with. So yeah, check it out. And yeah, with that, I'd like to thank you, everyone. If you want to check out the Task SDK and written in Rust, here are the links, as well as a project for this device. And yeah,